All right, good afternoon, CI. And this is Mrs. Wright. I am the accelerated math teacher at North Intermediate. And so I am going to get the opportunity to work with you guys for the next few weeks on some lessons. And so today what we're going to be doing is graphing inequalities. And so you hopefully have the handout that at the top has the word inequality followed by a blank space, and then there's a couple of tables. So if you will take that handout in front of you, then we'll get started. Just so you guys know, my first hour students are in class right now as well, so they will be possibly asking questions and things like that. And so if they have questions, I will repeat those questions for you all and let you hear the question prior to me answering it. Hopefully we'll be able to answer the questions that you guys would have if there was something that you were unsure of. If there are questions that you are unsure of, you're more than welcome to ask your substitute. And if that doesn't work, then you guys can write down a question, and an email can be sent to me, and I can address questions in later videos that you'll see in the week. So let's go ahead and get started today. Let's start by copying down the definition for the word inequality. You guys have actually worked with inequalities before. Inequalities are just things like greater than and less than, but we're going to add two additional symbols. If you'll look there, you see those, and we'll get to those in just a second. But basically, the definition of an inequality, and go ahead and copy this down as we're working, is, whoops, hang on just one second, is the relation between algebraic expressions that are not equal. In that next little part, it says an inequality uses one of the following four symbols. So two of those symbols you should know. The first one looks like this. So Jackson, can you tell me what that symbol means? That's correct. He said that symbol means less than. So let's go ahead and fill that in. All right, Gib, what is that one? That is greater than. Very good, Gib. All right, there are two additional ones that we probably haven't really worked with a whole lot, and the first one looks like this. Anyone have a guess about what that might mean? Luke. That is correct. This one means less than or equal to. So it's just basically taking and combining the less than symbol and the equal symbol together, and it creates a new inequality called less than or equal to. And then our last one would look like this, and I bet you guys can all guess and tell me what that means. Go ahead. Very good. Greater than or equal to. So today what we're going to be doing with these new symbols is we're just basically going to be taking algebraic expressions and we're going to graph those. The difference between an algebraic expression that we've done in the past is it has an equal sign there, meaning that the right hand of the equation and the left hand of the equation would be equal to one another. Now what we're going to do is we're going to talk about when they're not equal, but they represent a number or possibly a set of numbers that the answer could be. And so what we're going to focus on today is just making sure we know how to read them and graph them. And then tomorrow what we're going to do is we're going to pull in the ability to solve those equations. So you'll solve them like you would solve an algebraic equation, but then you'll, instead of them being equal, you would come up with a set of numbers that could make that a true statement, because they're not, just like the definition says, they're expressions that aren't going to be equal. All right, let's go ahead and move on. All right, down at the bottom, what we're going to do is we're going to complete this table. And so that first one tells us x is greater than a negative 1. And so what that's going to look like is we would use the variable x, and we would just use our greater than symbol, and that would be negative 1. Pretty simple. Just basically like writing algebraic expressions, which we did back in chapter 3, way back at the beginning of the school year. But now we are going to use these new symbols instead of equal signs. All right, we're going to come back and graph that in just a second. But before we graph that, I want you guys to look at the column that says possible solutions. So what's a possible solution that could go in there, Sam?
1.
Absolutely. 1, that would make this a true statement. 1 is greater than a negative 1, right? And so at this point, we could basically say that anything that is 0 or larger would make this a true statement. Okay? Now, as we graph these, there are different ways we're going to graph these. And so right now, out beside this, you have a number line already drawn for you. So I'm going to get one drawn really quickly for myself. We'll extend this a little bit. All right, so right here, that's what you guys have. So the way we would graph this is, yes, ma'am. That the question was, in the possible solutions column, do we put just one number, or do we put 0 or greater? At that point, you can just put any number that's 0 or greater. So you could, since Sam said 1, if you guys want to just use 1, then that's fine. We're just coming up with some possible answers there. So the way we graph this is it's not going to actually graph on the number line, it's going to be graphed above it. And because this answer right here, can negative 1 be a possible answer? Is negative 1 less than negative 1? It's not. So what we do is we right above the negative 1, we're going to put an open circle. Okay? And then what happens is, you guys just told me that a possible set of solutions could be 0, 1, 2, anything greater than that. So that means everything in this direction is a possible set of answers, and that's how we graph that. Yes, Stuart?
Why wouldn't you put it over the 0?
Because think there's numbers that fall in between 0 and negative 1, right? Yeah. And so that open note, what that open graph does, it says it can't include negative 1, but anything that is higher than negative 1, so it could be a number that fell in between 0 and negative 1. So the question asked, which was a really good question, is why would we not just put it over 0? Why do we put it over negative 1? And so the response again was because it could include a negative 0.9 or a negative number fraction that fell in between 0 and negative 1. So excellent question. The open note, and so what's going to happen is when it does include negative 1, it's going to look a little differently. And so that open note, or that open graph, just tells us that it can't include negative 1. Okay? All right, let's look at the next one. So the next one given to you is this right here. Can anybody tell me what you think that says? Not too hard. Kate. That's exactly right. So in the words column, go ahead and write out M is less than negative 2. And actually, just to save a little bit of time, I'm going to go ahead and I'm going to just keep coming back to this one graph every single time so that I don't have to keep drawing a number line over and over again. So I'm going to erase that, and we'll just come right back up here to this number line. And so if M is less than negative 2, we're going to go to the number that was given, and it's going to be open, because that means it cannot include negative 2. So we're going to put that circle over the negative 2, right? So which direction is that going to go? Which would make this true? Would it be to head in the direction of the positive side? Would that make it true? Or would it be to continue on to the negative side, Bren? Absolutely. So we would take, and to make that a true statement, it would go to our left. Okay. And so possible solutions here would be, Gib? Absolutely. A possible solution would be -3. I'll let you guys copy that into your notes. All right, I'm going to clean up the board just a little bit while you guys are getting ready for the next one. All right, next one. Okay, this one, the graph is given. So the graph looks like this right here. Okay, and it is pointing to the right-hand side. How does that look different than the ones we've been doing? Ryan? The circle is enclosed. So here's what this means. Where it says words, you can go ahead and copy this down. That one means X is greater than or equal to 0. X is greater than or equal to 0. And so the way that would look is we would put our variable X, and we would use our greater than or equal to symbol, and then it would be 0. And see, that's how that matches that. So again, we go over the 0. So that's how that time, that means it includes the 0. So that's why we fill it in, because it could be 0 or it could be something greater than 0. Okay. And so possible solutions there, Nathan, 1 would be a possible solution, absolutely. All right, we're going to pause for just a second. I'm going to let you guys go ahead at CI and here in my classroom, work on those last two, and we'll come back in just a second and discuss those. So go ahead and do that. All right, we are back live, ready to go over these answers that we just discussed. Or that we just completed. So I'm going to erase this and get going again. So that next one, you were given this right here. This is what you were given. Alyssa, can you tell me what that says? Good job. She said G is greater than or equal to -1, and that's what you should have written in your words column. A possible solution right there, Stuart. 0. 0, 1, 2, any of those numbers, right? You guys could have picked any of those numbers. And so when we go to graph that, right there, Lakin, what would that look like? How would we graph that? Very good. So she said a closed circle over the -1 with an arrow going to the right-hand side. Excellent job. Very good. All right, and then our last one here on this assignment. Okay. This time you are given the graph and you're asked to determine what that graph says. And so the graph we are given looks like this right here. And so, Macy, can you tell me what that says? She used the variable x, which is just fine. You guys can use whatever variable that you choose. And she said x is less than 1. Excellent job. That is correct. X is less than 1. Brady, what would that look like with symbols and variables? That's exactly right. Very good. And so a possible solution there, Ellie, might be 0. Or any other negative number would be working. Just again, take note that when we have a, right here, where we have just the greater than or just the less than symbol, then our circle is open when we're graphing. When we have less than or equal to, greater than or equal to, then our circle must be filled in. All right, we're going to stop right here. All right, so we're back, and I want you guys to have in front of you the assignment that says graphing inequalities. It has the word CUDA software, infinite algebra 1 at the top of it. So that is the paper that I would like for you guys to have at this point. So go ahead and get that passed out. So what I want to do is just work on graphing the inequality. We're also going to do some additional worksheets in just a few minutes that you're going to do independently, but I want to do a few more with you. So we have kind of talked about how we say it, how we write it, how we graph it. Right now I want to focus on graphing them, okay? So I'm not going to draw the number lines out for you guys. You have them in front of you, but I will draw, like, whether it's open or closed in the direction that it goes. And we're going to do a handful of these, and then I'm going to let you guys work on some of these on your own. So let's start with number 1. Let's start with number 1. Number 1 reads, n is less than or equal to a negative 5. Can anybody tell me what that would look like when we graph it on our number line? Luke.
A closed circle over negative 5 and an arrow pointing to the negative side.
Yes, very good. So what Luke said was a closed circle. There we go. And it would be over the negative 5. And then the arrow would be pointing to the left-hand side. Very good. Okay. All right. Next one, this is number 1. Number 2. Number 2 says n is less than or equal to 5. Nathan, what would that look like? Good. So Nathan said that we would have a closed circle over the number 5, and that arrow would be pointing to the left. Excellent. Number 3. Number 3 reads x is less than 1. Sam? Very good. So Sam said there should be an open circle over the number 1 with an arrow pointing to the left. All right, number 4. Number 4 reads r is greater than 2. Bryn, what would that look like? The right-hand side? Yeah. Okay, so she said that over the number 2, we would have an open circle, and the arrow this time would be pointing to the right-hand side. All right, number 5. Number 5 says n is less than 5. N is less than 5. Ellie, what would that look like? Okay, where would the open circle be? The open circle would be over the number 5, and the arrow would be pointing to the right. All right, so hopefully we're getting the hang of this. Anybody have any questions at this point? I know, CI, that I can't answer questions for you independently because we're videoing this and recording it, but I will answer any questions that my students might have. Maybe they would be the same questions that you have. Gib.
If the sign points a way, does the arrow also point that way?
All right, so that's an excellent question. So Gib's question was, if the sign, let's look back. So on number 1, it was n is less than or equal to -5 was the inequality that was given. Here, the inequality was n is less than or equal to 5. Number 3, the inequality was x is less than 1. And on number 4, the inequality was r is greater than 2. And on this one. So let me repeat the question one more time. The question was, what Gibb noticed is that the direction that the inequality is pointing is also the direction that the arrow is pointing. The direction the inequality is pointing is the direction the arrow is pointing. Over here, the inequality is now pointing to the right, therefore the arrow is pointing to the right. And while that is true for all of these, I want you guys to jump down to number 10 for a second. You can come back and do 7, 8, 9, and 10 in a few minutes, but if you will, please jump down to number 10 for me and go ahead and do that one for me, please. Anybody notice anything a little bit differently about this one? Kate? Okay, so did you notice that the location of the variable and the number switched places, right? And if that were just an equal sign, would that matter? No, because it wouldn't matter, because of an equal sign, both sides are balanced, they're equal in an equation. But because we're not talking about equations, we're talking about things that are unequal, inequalities, then now things are going to change a little bit differently. So what I want you to think about is that says -5 is greater than or equal to v. Can someone tell me a possible solution, a number that's a possible solution right there? Bryn? -6. So if -6, I'm going to switch this marker just so it stands out just a little bit more. If -6 is a possible solution, so let's replace that right here and see if that's a true statement. Is -5 greater than or equal to a -6? That's true. So what I want you to think about, if we have a number line right here, and we have, we'll just start with -4, -5, -6. That's really a 5 right here. This is -7, -3, -2, -1, all the way to 0. So if that were truly the answer, then what I want you to think about is this would be a closed circle over this -5 right here, but this would have to point in this direction. It would have to point to the left-hand side because we said that -6 is a possible solution, right? And so notice this time the arrow is pointing to the right on the inequality, but the arrow is pointing to the left when we graph it. So the question that Gib asked earlier, that is true if the inequality is on the left-hand side. But if the location of the inequality becomes to be on the right-hand side, then we can't use that as kind of a cheat method, right? And not that you're cheating, but we're kind of looking at the direction of the arrow, and it helps us know the answer a little bit easier. So this is an option. So this is something you have to look at. Now, an option that you could have, I'm going to change the color one more time. An option that you could possibly do right here is you could flip the sides of these, and all you do to flip it is you can put the inequality on the left-hand side, and you can put the number, or I'm sorry, the variable on the left-hand side, and you can put the number on the right-hand side. But what you would need to do is you would need to flip this inequality to make it be less than now for these to be equal, for these two equations to be equal, to be the same thing, you would have to flip the inequality. So if we come in and rewrite it as this right here, now we read it as v is less than or equal to -5, and -6 is still a true answer. -6 is less than -5, and now you'll notice the direction of the arrow is the direction that the graph is pointing. So that is just something that you can, if it bothers you, if you want to use that option, you can flip the number and the variable So you can flip sides, but if you flip it, you would need to flip the inequality as well. Macy. So the question says on a quiz or a test, is there something like where I would give a possible graph and then you would have to like a B, C, D kind of thing. So she's wondering, would there be like multiple choice questions where a graph was given and I may say, choose which letter is a possible solution, and absolutely it's a great way to ask the question. That's a possibility as well. Um, and just so CI that you know that Friday you will have a test over this material. We will learn the material today and tomorrow, and that test will be on Friday. At least it will be for my classroom, assuming that it works with the schedule that you guys have going on at CI as well. All right, if there are no other questions, we are going to sign off for today. Good luck, CI, and please let me know if there are questions. You can let your substitute know, and an email can be sent for questions you may have in addition to the questions you've heard today. Have a good day.